based on the presentation on the whiteboard over there. So the chi-square is actually the distribution for the degree of freedom. There is a non-parametric argument and non-parametric test. So this is the chi-square distribution. The more cell you got, it is being dispersed directly lah. Degree of freedom is equal to this and that. So chi-square started from 0. Chi-square never crossed this one. Okay, it started from 0. Okay, this is the tabulation of the chi-square. So there are two tests of the chi-square as I mentioned to you before. The first one is test for the goodness of fits, means you want to test the differences in terms of their proportion. Example, you want to test the proportion of male and female between in this classroom. You want to test male and female in your data set and so on. And then the next one is test of independence, where you want to measure the associations, means the relatedness. You want to measure the interdependence of the X and Y. Okay, goodness of fit. The purpose is actually test the assumption of the distribution on the categorical variable. Example. Okay, this is example. Okay, this is example. Let's say this one is your data. You got 5 group. 1 group, 2 group, 3 group, 4 group, 5 groups. How many groups you got here? 5. So what is your null? The proportions of the people got summoned, you know summoned? Got tickets lah, I mean got fined by the police officer will be similar across all this age group. Means that this one 20%, 20%, 20%, 20%, 20%. That is our null. So when we run the hypothesis testing after this, then we know whether it is similar across the different age group or not similar. Okay, you want to test this one or you don't want? You want to learn how to produce this table or not? Don't want. If you don't want, then we go to our data. Okay, then please go to your data. This is our data, data.cpr. Correct or not? Let's say we want to know whether the distribution of male and female are similar or not similar. How to do that? I make a repetition. Let's say we want to know the distribution of male and female are similar or not. So we talk about the goodness of fit. We are talking about goodness of fit, testing the differences of proportion or rates. Remember, proportion or rates ni, because the data is categorical data, nothing much you can do. You can just calculate the rate. This value over the total. This man over the total man and female. Macam tu. So, the first one is the goodness of fit, testing the differences between the male population or the male rate and female rate. So what is our step 1? Null. Correct or not? So our null will be proportion of male and female are similar. So what is our alternative? Good. Proportions of male and female are very good. Not similar. So you can see now, the chi-square is little bit different when we talk about same or not same, dia punya null and alternative. But the concept is clear there. That's why they have the O and E, observed and expected, the expectation of us. Of course, they will be same. In this particular data set, of course, we got how many samples? We got 31 samples. We expect male and female should be not differ. If the proportion of male and female is differ, what does that mean? That means the gender probably become something that you need to discuss further, because of maybe more females indicate more complaint, because female always complain. Correct or not? Something like that lah. That's why you must make sure if you conduct any statistical analysis, you have to run the descriptive statistic first to study the demographic holistic nature of your data. If your male and female are not different, then it's good. No worries, even though the numbers is different. Correct or not? Same also goes to the chi-square. If the numbers or the count or the observations of male and female are significantly differ, that means you have to look back whether it is influence or not influence. If not influence, then end of story. In this particular case, we just want to understand whether the proportions of male and female are similar or not similar. So the step number 2 will be what? Alpha 0.05, and then step number 3 is what? Run the analysis or calculate. Run or calculate and report. What you need to report? You need to report the chi-square values. So the chi-square values, ladies and gentlemen, will be look like this. You know X, this one. will be look like this. Okay, this is the chi-square value. It should be something like this. So the chi-square value probably must be, will be what? That is your argument lah. Chi-square value will be what? Okay, this is your chi-square value. And then of course, the next one will be your p-value. And then the next one will be step number 4. What is step number 4? Decision. Very good. Decision also same. P less than alpha. You need to reject your null. And then your p value is more than alpha. You have to fail to reject your null. Okay, and then the step number 5. What is step number 5? You make a conclusion, right? So the conclusion will be as follows. What is your conclusion? When you reject null, what happened? When you fail to reject. Okay, when you reject the null, that means you are going to say that the proportions are similar or not similar. You reject the null. Because the null said that the proportions are similar. When you reject the null, that means the proportion, yes, the proportion are not similar. That means there is difference. There is difference. Okay, that is the idea of conducting the, what is this? Chi-square. Oh, lupa lah. Okay, and then if you fail to reject your null, that means there is not the proportions are similar. That means there is no difference. There is no difference. In terms of what? There is no difference in terms of tabulation. In terms of the data tabulations. So, if you conducting any experimental design study, this is very crucial because you want to know your experimental group and your control group are significantly not differ. So how we want to defend those things? Using this kind of statistics. Okay, even though this one is 13, this one is 18, this one is 20, this one is 22, you want to prove it whether it is statistically different or not using the what? Chi-square. Very good. So how to do that? You go to the analyze, you go into the non-parametric test, you go into the legacy dialog and proceed with the first one here. You see? What? Chi-square. You go to the chi-square there, and then you insert the gender into the test variables. After you insert the gender as test variable, as default, the computer is already tick it for you. Already select it for you. The all categories are equal. So when you saw this one, all categories are equal. What does that mean? That means proportionately, the computer will understood based on your 31 data here. You divide by 2, you got what? 15.5, right? So that means male will be 15.5, female will be 15.5. You got what I mean? 31 divide by 2 because you got two groups, male and female. 15.5, 15.5. That is what the expectations that the computer already understood based on the all categories are equal. But if you want to change as according to your values as I indicated in front of you just now, you got the percentage and so on, you might want to add here. You can change the value also here to educate the computer to make sure the computer is understand the group 1 compare with the how many percent you write it based on the percentage value lah, which is 0.15 or 15.5. You write like this lah, 15.5. You add and then you add another one 15.5. Also can. This one is actually the expected values that you want to teach the computer. Okay. In this case, let's say I run it as equal and then I'm going to hit the paste button. After I hit the paste button, what is happening into my syntax? The syntax is already updated and then I'm going to observe this value is appear in my test. Okay, what you got? You got something like this, right? Something like what? I also cannot see it. Okay, this one. You see? The male is 13, the female is 18. Wow! So many female, ma. So it is biased already. No. Even though you can see in your naked eyes, the the female are dominant in these particular samples. However, the chi value is not more than 3.8, right? So it is not more than 3.8 as you already saw on our whiteboard just now. So that's mean we fail to reject the null hypothesis, same like this, right? So you see the chi value is 0.806. Therefore, the assumption significance will be more than alpha and you reject or fail to reject your null hypothesis. You reject or fail to reject. This one is 0.8 what? 806 and then your p value just now is 0. What? Oh, suddenly I forgot everything. 0.3 369. That means the p-value is more than alpha or less than alpha? More than alpha. You reject or fail to reject the null hypothesis? Ooh, wow, very good. You fail to reject the null hypothesis. So what is your conclusion then? Yes, fail to reject the null hypothesis, and therefore you are going to say that the proportions are similar. The proportions of male and female are similarly the same. If you don't believe me also, you can calculate it manually. You can calculate it manually, ladies and gentlemen. You have here observe, and then you have here expectation. You have here expected. Okay, how many male? How many female? How many male just now? 13 and 18, right? 13 and 18. So what is our expectation? Of course, you know that 31 divided by 2. So this is our expectation. Okay, this one also same, 31 divided by 2. And then observe minus expected, you got this value, right? Is equal to this one minus this one. Alright, you highlight this one. Okay, and then what is our observe minus expected? The power of 2. You can have this one lah, is equal to this one times by this one again. Correct or not? And then you observe minus expected divide by 2. Observe minus expected, the power of 2 divided by expected. Okay, it's equal to this value divided by the expected count. You got this one. So it will be similar. So you sum this one. Sum of this 0.8. Same? Same, right? 0.806. See? So when you got 0.806, that means you must use this one to compare to our table there. So where is my table? Oh, my table is already being transported over there. So if you saw inside the table, so where is the table? Never mind, because I got the internet here. I can type here chi-square table. Allahumma salli ala Muhammad. I forgot to spell it right. Okay, when you go to the chi-square table, for example, this one. Okay, sorry, this one degree of freedom so big. Okay, if you can see here, the degree of freedom for this particular table, you see, the degree of freedom will be 1, and then the alpha value will be 0.05, which is a 3.841. Therefore, our value is what? 0.806. That means it's inside or outside this value? Inside. So when inside, we fail to reject the null, or we also going to say that because of this, the p-value also indicate that the value of the p is more than our alpha, and that's why we fail to reject the null hypothesis. Faham tak? Faham kan? When we say that we fail to reject the null hypothesis, that means there are similar. There are similar proportion of the male and female distribution among the samples at the level of significant p less than 0.05. Where the chi value is equal to what? 0.806, and the p value is equal to what? 0.369. Okay, and then you can talk about the numbers and so on lah. That is the idea of the calculating the proportionate differences. That is the one example. Okay, ladies and gentlemen, did you understand or not?